So I'm repeating, normal distribution is the most important distribution, and also called Gaussian distribution, and it is developed from mathematics. The term, the model which is on the background, they are called radial basis functions. So there are a large number of probability distributions which are generated from normal distribution. We will study few of them in the statistics in the next lessons. One of the most important of them is the chi-square, chi, but we read it chi-square distribution, where the chi-square distribution then produces Erlang family of distribution. Erlang family of distribution is used in telecommunication and wireless networks. And then we have F distribution for variance comparison and D distribution. So there are a large number of distributions where normal distribution is the key towards these things. Second property is that when you have large sample size, for example, you simulated a data and you have 100 observation or 1000 observations, then it is called large sample in statistics. 100, 1000, 10,000, they are all called large samples. If we have large sample, then the data converges to a bell-shaped distribution. Bell-shaped means same thing like you have studied bell-shaped in first semester. Whenever we have large samples, every distribution converges to or converts to a bell-shaped or normal distribution. It is heavily used in artificial intelligence. For example, line following robot. So when you want to develop a line follower robot, like that a robot that follows a black line and keep moving, and on the background, that is the algorithm SLAM algorithm, and SLAM algorithm uses normal distribution. Similarly, our eyes, the human eyes, their shape is oval shape, and this oval shape also has a normal distribution. Or how we look in the visuals that we see, they are all follow this type of probability distribution. So there are a lot of many things, but we focus on covering this topic. Business analytics, like if you have everything normal, then you can make predictions, you can do decisions. Financial risk management, actuarial sciences, engineering applications. So whenever things are normal, that means English word normal. When things are normal, then we can assume that on the back end we have a normal distribution, normal probability distribution. What is the difference between? Yesterday, one student asked, "What is the difference between function and probability distribution?" So function is a term which is used by mathematicians, and the function, you get function values. You are not bound to have probability. But in case of probability distribution, you say that the integration must be equal to 1 and all values must be positive. So we restrict that all function values are being positive and the integration from lower limit to upper limit equals 1. This is a limitation on a function that's called a probability distribution. So every probability distribution is a mathematics function, but with two restrictions that I defined. So that's the difference between a mathematical function and a statistical function. This diagram I just representing here to show you that how the normal is in the heart of this all probability distribution. You see, most of the arrows are coming towards normal distribution. Poisson distribution coming towards normal, binomial coming towards normal. Log normal is a type of normal, beta is a beta coming towards normal. Every distribution either converting to normal distribution or is originated by normal distribution. So this diagram is a good presentation how normal is the core or heart of this statistical analysis. There are two types of lines. One is the dashed lines. The other one is black line. So this dashed line is presenting that your you have a large sample size. For example, if I assume binomial distribution, one is showing rather right. Why? Now, can you see slide number 3? So normal distribution is the center of all okay. So see that normal is the core. So dashed lines means you have a large sample size, and black lines means it is normal case. It's not. So in the next picture, you see we have another normal distribution, but it is saying something 0 and 1. I will explain you this later. When it is dashed lines, you see there are various conditions. You don't have to worry about this thing. The only objective of showing this diagram is that normal distribution is the heart or spine of all statistics distributions. Okay, so what is the function of a normal distribution? Normal distribution can be presented by x random variable following n stands for normal distribution. In normal distribution, we have two parameters. Mu stands for the mean value. This is the same mean that you have studied, summation x divided by n. And sigma square is the variance. Variance means, summation x minus x bar square divided by n or n minus 1. Because it is population variance, so it is called n divided by n. So normal distribution have two parameters. First is the mean mu, and second parameter is the variance sigma square. And the function form of this distribution, fx is equal to 1 over square root of 2 pi sigma square e power minus half x minus v divided by sigma whole square. So this is exponential component. And you see in exponential, we have something like x minus mu whole square. If you have any function like I am typing in the chat window, e power minus x square exponential minus x square. And if you want to integrate this function, it is not easy, because you remember in second year integration, you had that if you want to integrate some function, you require the derivative of the power along with it. So derivative of x square will be 2x, which is when we integrate this function, we will not have 2x with this function. So due to this reason, we can say that we cannot integrate this function. It's a complex function. Really, it is like, because of this square term, it is not a simple function. But we don't have to worry about integration. There are other alternative ways. Okay, first, I show the picture. So normal distribution is a bell-shaped curve. It can have a very high peak. It can have a moderate peak. It can have a low plateau peak. Maybe you have studied leptokurtic, platykurtic, or mesokurtic. Have you studied kurtosis, skewness and kurtosis in first semester?
Yes, sir.
Oh, very good. So basically you have studied. So you see that if you remember beta 2, which is kurtosis, if kurtosis is more than 3, that is called, I think, leptokurtic. So you see beta 2 is equal to 3 or greater than equal to 3, less than 3 or greater than 3. That means in first semester, we were comparing the beta 2 values with the value of normal distribution. So a simple normal distribution have beta 2 equals 3. If it is more than 3, we will say that the histogram or the frequency curve is higher than a usual normal distribution. And if beta 2 is less than 3, we can say that the function value is lower than or smaller than the standard or a usual normal distribution. So this means whenever we see this type of shapes, we compare with beta 2, 3 or less than or more than 3. Come back to, so this is the normal distribution. And the one property is that the three things, mean, median, and mode, they all lie in the center. For example, you see the center of this line is here. The center is here. So this center is the mean value or median value or mode value. So it's a one of the unique distributions which have all three measures of central tendency in the middle. It is symmetric. Symmetric means if you see this curve, you can see if you cut this graph from the middle, if you cut from the middle, 50% observations on the left hand side and 50% observations will be on the right hand side. So that's why it is called a symmetric. And unimodal means it has only one peak. It don't have more than one peak value. So, or in other words, you can say there is only one mode value, not two or three mode. This is also important that if you add normal distributions, then the resulting distribution will be again a normal distribution. So these are good qualities of a simple normal distribution. We are not doing mathematical derivations of, so that's the only property that we can explain. Because you see there are two parameters, mu, mean value, sigma square, the variance. That's why if I fix the mean value, suppose the mean value is here, suppose 50, mean is 50, and I am changing sigma square. When sigma square is small, we have a platocurtic. When sigma square is medium, the value is I think mesocurtic. And if it is sigma square is large, sigma square is the variance of the data. When variance is large, then we can say we have a leptocurtic. You see, there are three possibilities in a normal distribution when mean is constant and we are changing sigma square. Sigma square is the variance, sigma is the standard deviation. Say mean with different standard deviation. And second one is you see the location of the distribution is changed. The blue one is on the left, and if you slide it on the right hand side, so it becomes red color, blue color, then red color, then yellow color. You see their height is same, their spread, the spread of the distribution is same. The only thing is changing is their location. First location is left hand side, then move to right hand side, and then yellow one on further right hand side. So this is called change of location. The mean mu is called location, and sigma is called the spread. You see the bluish curve, the platykurtic curve is more spread comparative to the rest. This is the effect of parameters on normal distribution. There are two parameters. Any questions? One more property for normal distribution is that you can find, for example, um, for example, uh, there are 100 students in a classroom and they receive their marks in statistics module in statistics course. And suppose when we plot the histogram for those 100 students marks, we found that there is a normal distribution means how you can say for those 100 students marks or grades, you will make the histogram and you will see that it is bell shaped or right skewed. If I assume it is bell shaped, then from normal distribution we can say, we can infer that out of 100 students, approximately 68 students will be between mean. Suppose, let's say, I am typing in the chat window. Suppose the average marks are 65 and standard deviation is equal to 10. Suppose I say average marks of the students are 65 with standard deviation equals to 10. So mean, if I do mean minus standard deviation, it will be 65 minus 10 equals to 55. And mean plus standard deviation will be 65 plus 10 equals to 75. So that means how many students out of 100 will have grades between 55 and 75. I will say there will be 68 students who, sorry, I am just sending message. So yes, now you can see chat window. Mean 65, standard deviation 10. Then mean minus standard deviation is 65 minus 10 equals 55. And mean plus standard deviation means what I am doing, I am adding 10 and subtracting 10 from 65. I am getting 55 and 75. So two values we received. So based on these values, 55 and 75, we can say 68 students out of 100 students will have marks or grades between 55 and 75. So 68%, 68 out of 100 students will have grades between 55 and 75. So this is called one standard deviation away between mean plus minus one standard deviation. Similarly, this limit is saying mean plus minus two standard deviation. That means if mean is equal to 65, then if I do two standard deviation means 65 minus 2 times 10 is equal to 45. So if I do 45, so the lower limit is 45 and mean plus 2 times standard deviation is equal to 65 times plus 2 times 10 equals 85. How many students or how did you identify the polynomial? This is the formula. Here you can see minus mu minus sigma, mu minus standard deviation and mu plus standard deviation. And in the second case, we have mu minus 2 standard deviation, mu plus 2 standard deviation. And third one is mu minus 3 standard deviation and mu plus 3 standard deviation. That means they are very well defined. There is a background algorithm method that is called Chebyshev's. So the fundamental coming from Chebyshev's inequality, it should be taught in first semester. But if you have not covered, it's fine. And we can just say we are just assuming 1 standard deviation, 2 standard deviation, and 3 standard deviation. And how many observations we will have? We will have 68% observation, 95% observations, and 99.7% observations within these three limits. So if you have 100 students, so 68 students will have plus minus 55, sorry, 55 to 75, and 95 students will have 45 to 85, and around 100%, I mean, all students will have grades from 35 to 95. Everybody will have marks between 35 and 95. We are not talking about pass and fail. So pass and fail, we are not talking here because we just want to see the area under the curve. So this is the example, perfect example for area under the curve. Is it clear? So this is property. If you have any questions, so we will solve in the next after 2 slides. Standard normal distribution. One thing you notice here, maybe you see in normal distribution, if I am changing the standard deviation, I am getting different shapes. If I am changing mu is the mean parameter, again you see the distribution is changing. And if I change both mu and sigma, you will see a lot of different shapes with normal distribution shapes. Shapes means if some shape will be higher, some will be pretty vertic, some will be moving left and right. So in short, that means we can have infinite many different curves. If I suppose, because the mean can assume any value from minus infinity to plus infinity, and variance cannot be negative. So standard deviation or variance can take value from 0 to infinity. So that means there are a lot of many different possible values that we can assume. Therefore, we have to, and second thing, that we cannot do integration for this function. That means there should be something that we can use, something that can make our problem easier. So basically the CDF, if you remember first lesson, from first lesson, we saw that CDF is equal probability of x less than equal to small x. That means less than some specific value of x. Because x can take value from in normal distribution, the domain or the value of x can be from minus infinity to plus infinity. Therefore, we saw that a lower limit is minus infinity to x, and we integrate our interest is to integrate this function. But this is not possible based on the mathematics we have studied so far. What we can do is to use another type of mathematics, another type of integration that is called approximate integration or numerical integration. So in numerical integration, we replace this minus infinity by a number. For example, we can replace this minus infinity by -4, or we can replace it by -10 or -50. The more accurate results you want, the lower the value you have to assume. So this is the way to find the cumulative function, cumulative density function or distribution function for normal distribution. But there is one more thing, because you find this portion, this square term is difficult. You remember from second year. In second year, it was that if something is difficult, you start letting it. So for example, let y is equal to x square, and then you start integration or try to do integration. Similarly, here x minus mu divided by sigma is a difficult part. We assume that x minus mu divided by sigma is equal to z. This is called transformation, or this is also called Z transformation. So what happens with Z transformation? That if the mu can be minus infinity to plus infinity, and sigma can take any value from 0 to infinity. But when we do Z transformation, I mean this variable transformation, then the new distribution will exactly have 0 mean and 1 variance. It is explaining that in place of considering infinite many different values of mu and infinite different values of sigma square, we will have a new distribution that is called standard normal distribution, which will have mean 0 and variance 1. So this is very important transformation in any field. When we were doing a project in the UK, so we have a human factor analysis research that was showing that if a person is stressed or if a person is tired, he will not be doing a good driving on the highways or on the city area, urban area. So there was like they were using electrodes on the brain front in the front side of the head, and they were analyzing Z scores of the human signals, human brain signals. So from the human brain signals, it was found that if a person is tired or stressed, he will not doing a good driving. He will have red colors of the Z values. The color wise means red means the person is stressed or tired, and green means the person is fresh and he is okay for the driving. So this type of research also use that. So whenever if you type application of normal distribution, you will find a bunch of many different examples. So in place of integrating this complex function, we have another function which is a bit easier. This is called CDF for standard normal distribution. You see, in place of sigma square, now we have nothing here, which is that means sigma square is equal to 1. And in place of mu, we put 0. So x minus mu divided by sigma, we replace it with z, so it becomes z square. So this is called a standard norm. This function is called a standard normal distribution. But again, I told you, still we cannot integrate. Still we cannot do integration. So therefore, we use numerical integration. Numerical integration you will be taught in 4th semester. And there are a lot of many different methods for numerical differentiation and numerical integration. So why it is so important to have a standard normal distribution? Because as I explained, if we assume different values of mu and different values of sigma square, we can have many different normal curves. But if we standardize this, we will have only one curve with mean value, which is the center is 0, and standard deviation equals to a variance. Like we have done binomial distribution and Poisson distribution, we have a table for calculating probabilities from standard normal distribution, that is called Z table. It is very common and it is usually, if you Google, you will find hundreds of different websites showing this table. And if you want to find this type of probability less than equal to, you can directly find the probability from the table. That table is also called area under the normal curve table. But if you want to find right hand side probability, this is called area above the curve, above the point value. Then you have to 1 minus area under the curve. So that means that if you have greater than equal to sign, you have to reciprocate it. Total area is 1 minus that specific value. These three types of diagrams are showing how to calculate probability if we have two things, two numbers, A and B. A and B. So probability that Z value lie between A and B equals to probability of Z. That means upper limit, Z less than B. Upper limit is B minus lower limit. Upper limit minus lower limit, that gives us the difference. So that means if I want to find this area between A and B, it is equal to that I integrate this function from lower limit, which is minus infinity to B and minus infinity to A, and we which is in the center of this. So this is important because it's very simple, and we have Z table to calculate probability. Even I have shown you complex, bit complex functions, but you don't have to do any integration. You just have to know how to use the table, and that's it. This is the normal distribution table. By chance, it is showing that the table is starting from -4. That means it will start from -4 to 0, and from 0 to +4. So this table is now, it is interesting to note that there are two things. This is Z value. You see 0, 0 point minus 0.1, minus 0.2, minus 0.3. So if you have any number, for example, suppose 0.01. So you will see 0 is here, 0 is here, and the 0.01 is here. Are you getting me? So 0.01. If you want to find 0.01, so first decimal, one point after decimal, you will see in this column, and the second decimal place you will find in this row. For example, if I want to find, I'm typing in the chat window. For example, I want to find minus 1.51. If I want to find minus 1.51, I will go to minus 1.5 here, and the one value, the second decimal place is here from column 0.01. So this is giving me 0.06552. Are you getting this example? So minus 1.51, I want to search minus 1.51. So minus 1.5 here. That will have one decimal number, and the second decimal place is from the column, which is 0.01. So you will have to concatenate them. So minus 1.51 equals minus 1.5 concatenation 0.01. So it's giving us 0.06552. So this is the way. One more example, if I ask you, suppose I want to find minus 2.55. If I want to find minus 2.55, can anybody answer this? Chat window is open. Minus 2.5, this is here. And where is the second 5 number? This is second 5th number is here. So I come along this column, coming to this point, and I found this is the value. Okay. This is the value, 0.00538. So what I have to do, minus 2.55 equals minus 2.5, concatenation operator, and what is the next one? 0.05. So that means if you want to see any number in that table, you have to see the row and you have to see that particular column. This is the way to see normal distribution. In the A-level statistics, there is even more stage where you have 3 decimal place numbers like 2.555. Then you have a further complication. And if you Google, there are online calculators that you can use to find the probabilities. So I think I have given reference here. If I show you, this is a website, online stat book. Mean 0, standard deviation 1. So this is called a standard normal. What I want to find, for example, minus 2.55. Minus 2.55. I have this radio button. If I calculate, so it is giving me 0.0054. Same answer that is given by the table. And similarly, if I want to find minus 0.01, So it is minus 0.01. So it is showing 0.4 something, which is 0.01 is a big number. It's close to it. Yeah, it's close to 0.5. It's close to 0. So that's why the area is nearly 0.5. One thing you notice here, you should notice here, that in a standard normal distribution, the mean value is 0. Left hand side values are negative and right hand side values are positive. So that means if it is not a standard normal distribution, you will have 50% values below 0, which is negative area, negative z values, and 50% values are above 0, that means positive z value. If I change them, if I say example, I say 5 standard deviation. See, it just changed from 0, 1, 2, 3, 4 to 0, 5, 10, 15. And if I change the mean value to suppose 5, so it changed here. Mean is 5 and 0 is on the left side. This the positive values on the right. So, but in the standard normal, because the table we have is for standard normal, I will keep them as 0, 1, 2, 3. And you see -1 standard deviation, -2 standard deviation, -3 standard deviation easily from this website. And you will see that there are all different tables available here. We can use this to calculate probability. But in your test, you will be given this table, this normal table to calculate probability. This table. It's I think 2 or 3 pages long table. Now we start doing an example. Now take this session. Anybody have any question? Then we will start again in 3 to 5 minutes. We will start with this exercise, and there are few questions and why it is important in data science. I can show you some examples as well, how it is applied. I will skip this and then follow this one. Okay, thank you.